Hi, welcome to video 9.3b, Sum and Difference of Series. This is not in the textbook, but before we get to that, doing series on the TI Nspire CX Cache, you're going to use the template to access the sigma notation. If the series diverges, you will get the sigma notation as an answer. If it converges, it will approximate the number it converges to. Every once in a while, trying to use infinity will backfire on you, and you can just replace it by a large number. So, for example, if you do summation, let's do one we know. Let's say n goes from 0 to, and we'll call it infinity. Of, let's say, 3 parentheses 0.5 to the power of n. Okay. Now, you should recognize this is a geometric series. First term is 3, common ratio is a half. It should converge to 3 over 1 minus a half, which is 3 over a half, which is 6, and that's exactly what you get. Now, let's do the same idea, but I'm going to change the, I'm going to change this to 1.5, making the common ratio bigger than 1, and it'll diverge. So you'll either get infinity. As I said, sometimes you'll just get the thing back again. If that's the case, replace that infinity by a very large number. Okay, so this is not in the book, and this is the whole sum and difference. It says, oh, this is a different one actually. This says if the series AN and the series BN are two infinite series differing only in their first n terms. In other words, let's say this series starts, I don't know, 1, 2, 3, 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc. And this one starts at 4 and goes 4 plus 5 plus 6. So basically this series is this series minus the first 4 terms, okay? Then, if that's the case, if they differ only by the first few terms, then either both series converge or both series diverge. So if one converges, the other converges. If one diverges, the other diverges. So here's an example. Summation n goes from 5 to infinity of 1 over n is 1/5 plus 1/6 plus 1/7. This is not called the harmonic series because the harmonic series would have to start at 1. But this is the harmonic series. It just differs from it from the first 4 terms. It only has the first 4 terms missing. So the idea is, since the harmonic series diverges and this series is the harmonic series with the first 4 terms missing, this series will also converge. Okay, also not in the book, and this has to do with what happens when you add or subtract two convergent series, what happens when you add or subtract a convergent with a divergent, and what happens when you add or subtract two divergent series. So if you add a convergent plus a convergent, it makes sense your answer is going to be convergent. So let's say this converges to 5 and this converges to 3, then the sum will converge to 8. Or if this is a minus, then it would be 5 minus 3, which would converge to 2. Now, if this converges to 5, but this goes to infinity, it would make sense that 5 plus infinity should diverge. And sure enough, if you have one of each, it's going to diverge. The interesting one is the divergent plus or minus divergent. You actually could end up with convergent or divergent in this case. So if you take, for example, 1 over 4n plus 1 over 4 to the power of n. So if I break that up, okay, and I'm going to see whether each one of these series converges or not. So certainly this one right here is a geometric series. The common ratio is 1/4. Since the absolute value of r, which is 1/4, is less than 1, the series converges. So I know it converges. This one over here, 1 over 4n, if I pull out the 1/4, I have 1/4 times the harmonic series. Well, we know that the harmonic series diverges. 1/4 times a divergent is divergent, and a divergent plus a convergent is going to give a divergent. So, Let's have a look at another example. 1 over n minus 1 over n. If I was to split it up, the problem is that they're both divergent. And when they're both divergent, sum or difference, there's no conclusion. If that's the case, then what you should do is you should actually simplify the expression, which in this case becomes 0. And you find out in this case it converges. If I take, now this was 1 over n minus 1 over n, if I take 1 over n plus 1 over n, if I tried splitting it up, again I'd get divergent plus divergent this time, still no solution. But here I'm going to simplify, I'm going to actually combine the fractions, and I'll pull out the 2. You have 2 times the harmonic, which is 2 times the divergent, which is a divergent. So as you can see, we had divergent minus divergent eventually gave convergent, but here divergent plus divergent gave divergent. So you really won't know. Okay, so this is from the worksheet. Guess this is it here. Yeah. Okay, so determine if each series, this is for 9.3, is convergent, converges or diverges. If convergent, find its sum. So for number 44, you have 5 over 4 to the n plus 4 over 5 to the n. So we're going to try and split it up because combining them is going to be a bit of a hassle. And it turns out that this one over here is, if you write out the first few terms, it's geometric. Common ratio is 1/4, so it does converge. This one over here, also geometric. As you can tell by writing out the first few terms, common ratio is 1/5. And again, it is also convergent. So I do end up with convergent plus convergent is convergent. But they're also asking what it converges to. Well, if I finish off this one on the left, I now know that it converges to the first term, which is 5/4 over 1 minus the common ratio, which is 5/4 over 3/4, which is 5/3. So that one's 5/3. And this one over here converges to its first term, which is 4/5 over 1 minus its common ratio, which is 1/5, which becomes 4/5 over 4/5, which is 1. And therefore, I have 5/3 plus 1, which is 8/3.